right, so we're starting topic 4 today. And I'm trying to record this, practicing, so it's not going to be perfect. Bear with me. See if I can see this. The title is, it's on screen record. The title is called Euler's Number, and it is spelled Eulers.
In section 9.
Yeah, sorry, still in section 9. It's called Euler's Number. I know it looks like Euler's number, and that's what I've said forever. But on Algebra Nation, they said that a proper enunciation is Euler's number. Target. What is meant by Euler's number? And how do you evaluate a problem involving Euler's number? So y'all are still going to make your notes just like you have been making them. Cornell notes with the margin on the side for the questions, important concepts, targets, and the summary at the end. It's just I don't have a lot of space to write all this, so I won't be showing that, but you'll still want to do that and include that stuff when you turn them in. Okay? All right, so for the notes. Consider the following expression for compound interest. P, open parentheses, 1 plus R divided by N, quantity raised to the NT power. Where P equals amount of money invested, R equals the percent rate as a decimal. T equals number of years. And N equals number of times compounded in a year. Sorry, what? R equals percent rate as a decimal. Does everybody have that before I move on to the next page? I can move on? Okay. N is the number of times the money in the account is compounded in a year. N is the number of times the money in the account is compounded in 1 year. Let's look at a chart. We will use the formula (1 plus 1 divided by n raised to the n, which assumes $1 was the initial investment, for 1 year at a rate of 100%. So we're just using 1 for everything, just for easy calculations, just so you can see how your money grows when your investment. We're only talking about $1. Okay, so obviously it'd be a lot different if you're talking about $5,000 or $10,000 or $50,000. Do y'all know what compounded means? So when you invest your money, the bank will compound your money. That means every time it's compounded, they are calculating how much interest that you've earned in your account. And then they're putting that interest into your account. So the next time they compound your money, they took the money you started with plus the interest you accrued. So you're earning interest on your money plus the interest that you've earned, okay? So the more times that the bank compounds your interest in a year, the faster your money will grow. If they only do it once a year, it's not going to grow as fast as if they do it once a month, okay? Or even once a quarter. So that's what we're looking at. And again, we just use $1 for the initial investment for 1 year at a rate of 100%, just so it makes easy math. How many people took financial algebra last year? So you took financial algebra. I know at least when I taught it, we did a lot of calculating interest on money. It seems like that whole course was the main topic was calculating interest that you could earn. All right, so I'm going to go to a new page. Is everybody good with this? Because my chart, I need some room. All right. So we are going to have a little chart here, and we need 3 columns First one we'll call number of times compounded. The second is just n, and remember, well, n is actually the number of times compounded. The first column will be, well, you'll see when we do it. And then we're going to do e of n, which basically means the amount in the account after it was compounded. Okay, so if our interest is compounded yearly, that means it is compounded once a year. Okay, so if we substitute into that formula on this page, if we substitute a 1 in here, we would get 1 plus 1 divided by 1 raised to the 1. Well, that would be 1 plus 1 is 2 raised to the first power is 2, right? So if our interest is only compounded once a year, then at the end of that year, we would have $2. If our money was compounded semi-annually, gotta get used to this thing. That means it's compounded twice a year. So in that formula, we would substitute in a 2 for n, and we would end up with $2.25. So that's not a huge difference, but it's more than if it's just compounded once a year, right? And imagine if that was $10,000 in your account, right? That would be even more money. If your money is compounded quarterly, how many times a year do you think that means? 4 times a year. And you would have approximately 2.4414, so about $2.44. More than if it's compounded once or twice a year. If it's compounded monthly, that means it would be compounded 12 times a year, which is 2.6130, so about $2.61. Weekly, how many times is that going to be? 52. And we would have 2.6926, so about $2.69. If it's compounded daily, 365 times a year. And that would be 2.7146. It could be compounded hourly. Anybody know what that's going to be? 8,760 times. And you get 2.7181 by the end of the year. If it's compounded every minute, that would be 525,600 minutes in a year. Obviously, we're not talking about leap years here. We're just talking about the regular old 365 days. And you would get 2.7183. So but still about $2, and if you're rounding up, 72 cents, just like hourly. Every second. I don't know if they actually compound money that often, but we're just trying to show you, I'm trying to show you something that's going to, that's going to happen. You might know how many seconds are in a year? A lot. What?